Hello, everyone. So we are starting Unit 2, and we're going to be dealing with rational expressions and equations. Our first topic that we are going to go into is simplifying rational expressions. So we need to remember a couple of things because factoring is going to be a huge part of the first step, okay? So the idea is we're going to simplify it, just like fractions, just like it says here. So 20 over 12, right? So 20 over 12 is 4 times 5, right? And 12 is 4 times 3. And these two 4s would cancel out, leaving us with 5/3, right? We've done this when we were in grammar school and simplifying our fractions. We're going to do that, but we're also going to have variables involved with it. Now, this right here is very important, okay? And I'll show you in an example that we do later on in the lesson right here. You cannot, when there's addition and subtraction, you cannot cross off these two. So see how I can cross off the 4s, but it's because it's multiplication there. When there's addition or subtraction, you cannot cross out. This cannot happen. Don't do that. Like I said, we'll do an example later on that I will show you what some students do that I don't want you to do. Okay. All right. So let's remember our factoring. Always looking for the GCF first. Some of you forgot to do that last chapter. And then there's different things that we can do. If we see a difference of squares, right? What does that mean? And factor that quickly. Or how do we factor, whether it be using your box method or your grouping, okay? And then we have domain restrictions, okay? So domain restrictions, meaning it can't happen. Because as you can see with fractions, right? And this is what rationals are. We cannot divide by 0. That denominator cannot equal 0. And we kind of touched base on that last chapter a little bit, but we're going to do it a little bit more this chapter. So we have two types of domain restrictions: vertical asymptotes and points of discontinuity. Points of discontinuity are also called holes. Okay. So again, remember that we are not allowed to divide by 0. It is undefined. So vertical asymptotes will come from the factors in the denominator that do not simplify. You look at the factors that remain, and then this is how your answer is supposed to be. X equals a number because it's a vertical asymptote. It's a dotted line, right? It can't cross. Points of discontinuity, or your holes, will come from the factors in the denominator that do simplify. So in other words, it's what is crossed off. Okay, so it's what is disappeared. And the point of discontinuity is a point. So when you have an X value there, you must solve for the Y also. Okay. So what does this mean? Okay, well, here's a filled out example of what you're going to do. So here's our rational function or expression. And what we're going to do first is we're going to factor the numerator and denominator. So you use your box method or your grouping. Then what happens, see how there's multiplication right here. You're able to cross off, okay, leaving x plus 2 over x plus 3. The biggest mistake people make right here is they cross off the x's. You can't do that. There's addition there. All right, so let's talk about our discontinuities. Our discontinuities, we look at the denominator to begin with in our simplified version. So x plus 3. So we ask ourselves, what x makes that 0? And you can just solve it algebraically if you want. So we have a vertical asymptote at -3. Now, the point of discontinuity comes from what we crossed out. So you take what you crossed out, set equal to 0, and solve. Now, of course, when we solve, we get x equals 4, but it's a coordinate pair. So what you then have to do is plug X value into the simplified expression. Okay, that's how we got the Y value. Okay. Now on a graph, well, what does that look like? Well, there is our point of discontinuity, that hole right there. And then this right here, it's printed out dark, but is your vertical asymptote. In other words, it gets really, really close, but it doesn't cross. Okay. All right, let's look at some examples that we can do. Simplify, identify any vertical asymptotes and points of discontinuity. Excuse me, guys.
If you are riding a bus, please proceed to your bus stop. The buses are arriving.
Sorry, guys. It's the end of the school day.
Please proceed to your bus.
Okay,
Thank you.
so the first thing we're going to do is factor. But of course, as you can see right here, it's kind of hard to do that factoring because it's not a trinomial. It's not a quadratic there. But we have to think of it like our normal fractions, right? So 40 is actually 8 times 5. And then we have these 4 x's. Now I'm doing this, I'm like breaking it down to the smallest thing. If you guys can recognize it right away, go for it. And then we have 8 and x times x. So now I'm going to start crossing off things. Okay. I see my 8's can cancel and a couple x's can cancel. Right. Okay. So what does that leave us? What is that simplified expression? Well, that leaves us 5x squared. All right, perfect. Now let's talk about our vertical asymptotes. Remember, and our vertical asymptotes come from the simplified version, what is in the denominator. And as you can see, this denominator would be 1. So it can never be 0. So we don't have any vertical asymptotes. Now our point of discontinuity, or our hole, that comes from what we crossed out. Now 8 can never be 0 because it's 8, but we crossed out an x. So on the side here, I might say x equals 0. Remember, set what you cross out equal to 0 and then solve. Oh, what do you know? We already solved it, right? X equals 0. So we know there is a hole at 0. But what we do need to find out is where that hole is. So what we do is we plug that x value back into the function. So 5 times 0 squared is 0. So there is a hole right at the origin. All right, let's try another one. Now, example 1 here, we have, I factored it for you. Okay, because I just wanted you to focus on if this were factored, what would we do? Well, as you can see, you can cross out the x plus 2's. Okay, so our simplified version, because we always have to write that down, is x minus 5 all over x plus 4. All right, next. Domain restrictions. So vertical asymptotes. Remember, vertical asymptotes come from the simplified version. What makes the denominator 0? So you can either take the denominator, set it equal to 0, or not equal to 0, because we don't want it to be there, and then we can solve. Or if you can just look at it and tell, hey, we have a vertical asymptote at x equals -4, you're all good. Point of discontinuity. All right, that comes from what we crossed off. What did we cross off? We crossed off an x plus 2, set that equal to 0. So x equals -2. Now, of course, this is the point though. So I'm going to start putting in the coordinate pair of -2. And then what I need to do is I need to plug this right back into the simplified version for the y value. So -2 minus 5 is -7. And then -2 plus 4 is 6. And we're done. Well, I just bit my cheek. Sorry, guys. All right. What I want you, let's do another example before we do some of our checks, okay? Simplify, identify any vertical asymptotes and points of discontinuity. Okay, so in this case, it's not factored. We have to factor it first. But when we factor, what do we always look for first? GCF. So let's take out of the numerator, we can take out an x, right? So x times -5 x squared plus 4x plus 6 all over x. Now, guys, we do not have to factor this anymore because look what happens. The x's will cancel. So our simplified version of this is -5x squared plus 4x plus 6. I don't know why I'm putting parentheses around there, but I'm just in that mood then. Okay, vertical asymptotes, remember that comes from our denominator. So do we have something in our denominator that's a variable? No, we don't. So none. Point of discontinuity comes from what we crossed off. Well, set what we crossed off, which is x, equal to 0. That's great. We don't have to solve anymore, right? But we do have to put it in a coordinate pair. And remember, how do we find that y value again? We plug it into the simplified. So when you plug in 0 to that, you get 6. Okay, pause the video, do the first 2 questions on your check sheet, and then we can move on. All right, next. Just 2 more, and then you guys can do some practice on your own. So, same directions, don't need to worry about explaining them. So again, the first thing we do is factor. Here's our trick one though. If you look at the numerator, what is that? That is the difference of squares. So remember, take the square root of both. One's adding, one's subtracting. And then the bottom is already factored. Make sure you cross off the right one. So that means our simplified is x minus 2. Vertical asymptote, well, in the denominator, we don't have a variable, so none. Point of discontinuity. Well, what did we cross off? We crossed off this x plus 2. So we're going to set that equal to 0 and solve. Okay, that is our x value of our whole. Now, where do we plug it in? We plug it in our simplified. So -2 minus 2 is -4. All right, let's see if we can just get a little bit more trickier. All right. Greatest common factor. Look at that numerator. What's in common? 2x. Did everybody see that? So leaving us with x squared minus 5x plus 4 all over. Let's look at the denominator there. They have an x in common. X squared plus 2x minus 3. All right, that was just the GCF. As you can see, we still have quadratics there. So I'm going to figure out if I can factor even more. So keep that 2x out front. Now, I'm going to do this quickly just so you guys don't have to go through it. But if you are struggling with factoring, make sure you talk to me. Okay, so if I were to factor this quickly, I would see that this would be x minus 1 times x minus 4. The bottom one down here is x plus 3 times x minus 1. Again, you guys can use your box, your grouping, whatever you need. Okay. All right, we broke it down. Now we need to cross off. What's in common? I see an x minus 1 is in common here. I also see an x. Now, the reason why I can do this x though is because look, it's multiplication there. So I can cross those off. So my simplified leaves us in the numerator with 2 times x minus 4 all over x plus 3. Okay, let's talk about a vertical asymptote. What's in the denominator? Set that equal to 0 and solve. So x equals -3. We have a vertical asymptote at -3. Our point of discontinuity comes from what we crossed out. If you look, guys, we crossed off 2 things, which means we have 2 holes. So the first one we crossed out was x. Set that equal to 0. Yeah, great. We don't have to do much, huh? Except plug in for that y value. Remember, we plug in to the simplified. So on top, and if you need to use your calculator, do it. 0 minus 4 is -4. -4 times 2 is -8. All over 0 plus 3 is 3. So we have a hole right here. We need to do the second part, which is x minus 1. Set that equal to 0. So x is 1. Okay, that's the x value of our hole. Plug that in. 1 minus 4 is -3. -3 times 2 is -6. And then 1 plus 3 is 4. Now I'm okay with this. Be careful on the computer though, it might make you reduce to -3/2. Okay, check those other 2 on your checklist and come get me if you need help or just to make sure you're on the right track.